Maybe we can continue so we don't run out of time. So yeah, so now we are going to talk briefly about use of AI models, particularly ChatGPT in this example, in programming. So the idea is that, well, it's a new thing for all of us, so we wanted to demonstrate how this works. I would like to remind you that the guidelines we have regarding the use of AI tools in this course are the same. So refer to what we had told you earlier in the first lesson. Just we are showing you examples of how this works, so you would be familiar with the pros and cons of using this in your work. And of course, as people, well, you are new to learning programming, so it's like using calculator in elementary school when when you're just trying to learn mathematics. So we don't encourage you to use it too much, so you can learn how programming works before taking shortcuts. So
Maybe I'll just add one very quick thing that, yeah, we do have one kind of optional problem in this week's exercise where you can use ChatGPT to work on it, but it's optional, so it's it doesn't count for any points. It's mostly just that if you want to try out how to use these kind of generative text tools like ChatGPT, that you can do that because it can produce text like you might have seen, but it can also produce code,
yeah,
as we will see.
Yeah, so AI, you probably all know that AI is short for artificial intelligence, and it refers to the field of computer science dedicated to developing systems that are smart enough to do things that we humans can do, many of the things we can do. So large language models, or LLM for short, is a group of is a type of artificial intelligence which is good at processing like human languages. So you can just talk to them in plain language, English or whatever your language you want. It understands you to some extent, and it can provide you with a response in the same language. So ChatGPT that we are familiar with, we have been hearing a lot about it during the past year, is a good example of this large language model. And it's also good at producing code in different languages, and we are going to have a look at that today. So as David said, this is optional, but if you want to try this out, you need to have an account for ChatGPT. So you have to go to the OpenAI website. OpenAI is the company that is behind ChatGPT, and you need to open an account if you want to try it out, and it's pretty much like opening an account on any other internet website. So you just provide email. It also requires you to provide your phone number and date of birth. So if you want to sign up, it's your own choice, you don't have to. So you have to provide that information. You have also the option of signing up by linking your account to other existing accounts like Google, Microsoft, or Apple. So you also have that option. And once you sign up, you get a confirmation email using which you can activate your account. You also get, I guess, a text message so you can activate your account. So once you log in using your ChatGPT account, you will see this kind of window. Maybe I open mine. So this is what ChatGPT looks like. So on the left, you have a history of the conversations you have had with ChatGPT before. And here you have a send message box, which is an area where you provide ChatGPT with a prompt. So what is a prompt? Prompt is a specific instruction that you provide to the machine, to the computer program, and it performs some kind of task. So basically just provides a way of communicating with the AI. So let's start by writing a very simple prompt. So I'm just going to copy it and try it in ChatGPT. So I'm asking ChatGPT to write a Python function that adds two numbers. So it just creates a function that does that for you. So we have run this before, and we have the example of the code on the notebook. So let's try how that works. So it just gives you a function called add numbers that takes two parameters as input, and it just returns the sum of them. So I just ran the function, the definition, so the function should be accessible. So earlier time when I tried this, it just defined a function. It didn't show how to use it. So that's one of the things. So every time you run a prompt, you do not necessarily get the same answer. So last time I asked for it, it just gave me this function. Then I had to run another command, another prompt to ask ChatGPT to also give me an example of how to get the output of the function through an F string. So what I did, I just added this new prompt and I got the new output. And this new output is just demonstrate, well, we have the definition of the function, and then it just demonstrates how to use it. So you have one example. So you have two numbers, 5 and 3, and then it just prints out the sum using this F string. So let's see how it works. Yeah, the sum of 5 and 3 is 8. Yeah, so what happens that when you're talking to ChatGPT, it remembers your conversation. So if you just ask ChatGPT to do something new based on what it has done before, it remembers that it has previously given you this function. So if you add it to do something else, for example, now we have been talking with ChatGPT about like writing this function. Now we can ask ChatGPT to add inline comment to make the code more readable for us. And once you ask for that, so add inline comment. Yeah, it's taking a while. But basically what it does, it just remembers what it has given you before, and now that you ask for inline comment, uh, it has added some comments here. Not very detailed, but yeah. Yeah, so when I ran this earlier, this was the output I got. Yeah, so it does quite a good job doing this very simple task. Yeah, as I said, the same prompt can yield different responses. So if any of you is doing this at the same time as me, you are probably getting different responses, and there are a number of reasons why this happens. One is that there is a factor of randomness in definition of these models, and basically it's because they want to make it a bit more human-like, so you don't always get the same response. It's not always as predictable. So there's some randomness factor there, and of course it also remembers all the conversations you have had with it. So everything you tell ChatGPT, you have said before, it provides context, so it affects the answer it gives you. So these are some of the reasons why you might get different responses every time you talk to ChatGPT. So let's try another prompt here. We ask ChatGPT to write us a Python function that converts degrees Fahrenheit to Celsius, similar to what we did earlier today. So this is the output I got from it earlier. Yeah, so it just defines a function called Fahrenheit to Celsius. It also adds some comments explaining how it has been done, and it just does a basic calculation for you. Yeah, so let's try this and see how this works. Maybe to save time, I can just copy the text from the course's website. Yeah, so I forgot to run the function. So the function wasn't defined yet. Now that it is defined, so you can get the output. So one thing that is very important when you're working with ChatGPT is to write good prompts. So that's the only way of communicating with ChatGPT. So you have to write good prompts. So what it makes a prompt good? Well, first of all, you have to be very clear with what you want. So you have to clearly say what you want and what are your clear objectives. So if you're vague, that's, well, ChatGPT will just start making assumptions on what you possibly want. But if you're clear, then it knows what you want. You get a more accurate answer. And you should provide as much context as possible to so that ChatGPT understands what is the context within which you want to solve this problem. And you should, if possible, you should provide clear instructions for ChatGPT to do this. So earlier I ran a prompt, a function to convert Kelvin to Newton. So you can try that as well. This is something we did today earlier. So the response it gave me the first time was totally off. So it's just, well, it's just confusing Newton with the unit of force, the Newton law. So it's just multiplying the mass by acceleration to give you the force. So this is not what we want. If I do this now after asking about temperatures earlier, probably it knows the context, so it would give me the right answer. But when I ran this first, it was like when I had just created my ChatGPT account, so I hadn't talked about temperatures at all. But now that we have been talking about temperatures, if you ask the same thing, it knows that by Newton you mean Newton, the temperature unit, not the force unit. So yeah, so that's the importance of context. In this prompt, I hadn't provided good enough context, so it just got confused and gave me something wrong. So the way to improve it is just to be more clear. So next time I ask a function to convert temperature in Kelvin to Newton. So now it knows the context better. It gives you a better response. So this is more uh, better solution. But there is still something wrong with this. Can anyone tell? So this is the response I got earlier from ChatGPT. It looks better, but there's still something off. Does anyone know?
We can skip using the poll. You can just, if anybody happens to see anything wrong here with this conversion. I know we only very briefly saw this conversion from Celsius to Newtons earlier. Any guesses? Yeah, exactly. So what we got out of here looks halfway decent, but what it's actually doing is it's converting directly the temperature in kelvins to newtons, and that should be a conversion from Celsius first in order to work with this kind of conversion factor. So in order for this to work properly, it should first have to subtract 273.15 from the Kelvin temperature and then multiply by 0.33. So this example, the part of the reason why we put it into the lesson is because it looks right. And if you were just sort of saying like, hey, ChatGPT, do my homework, this would probably look good enough for you to turn this in for your solution to the exercise, but it would be wrong. And this is part of the reason why it's good to know about these tools and that they exist, but it's also good to be very kind of skeptical and look through the results that are produced there, because it's very easy to be misled with things because it looks so human-like and it looks so much like the code you would generate. You need to be a little bit careful.
Yeah. So let's test this function, but there are problems with that, as David said, but let's try to test it. So we want to, I just copied the code to make it faster. So imagine we have a list of temperatures in Kelvin, and we want to convert that to Newton using this function that ChatGPT has made us, and actually it was wrong, so now we know that. But let's run the function. When you run the function, you get this error. It's just telling you that, okay, because we provided the function with a list and the code was meant to work with not a list, but just integer or float value, and you get an error. So in this case, it was multiplying the list by float, which in Python results in an error. Even if it wasn't float, it was integer. Maybe you wouldn't have gotten an error, but then you would have gotten a very wrong answer, because when you multiply a list in Python by integer, it just repeats the sequence. It doesn't multiply the value. So in any case, you would have gotten either an error or a wrong answer. So another reason why you should be careful and very specific with what you want. So if you want to provide the function, but there are better ways of doing this. It's just an example, not the smartest example maybe. But if you want to really provide a list as an input for your function, you have to be specific and tell ChatGPT that the input will be a list. So that's what I did next time. I was a bit more specific and I said, okay, I want to convert a list of temperatures. And then ChatGPT gave me a better response. Now it can take in a list as the input. So let's see how that works now. Okay, yeah, so now that we are more specific with our prompt, it gave us a function that works with the list as the input. Okay, so another example, we asked ChatGPT to create a Python function that classifies an input temperature to 5 classes. This is another example of a bad prompt because we are not specific. First of all, we are not saying what unit of temperature it is. Is it Fahrenheit? Is it Celsius or what? Or Kelvin? And we are not providing any information on like classes based on what. So we are not providing any instructions for ChatGPT. So again, it goes ahead and creates a solution based on assumptions it makes. And this is the solution I got earlier when I ran this. So there are a few problems with that. First of all, it's like the solution is just weird. You see, it's a function within a function, and that's totally unnecessary in this case. And you can see the output is it's 6 classes actually. He asked for 5 classes, so it's counting the if cases, but it doesn't count else, which is another class actually here. So this is the solution it gives us. So it's actually working. So if you just run this weird solution, you get the output you want. So it's just telling you, for example, 35 degrees is cool, but uh, but this is a weird solution. So we can just improve this. Let's just like the other function is just weird. Let's just copy this part. Yeah, so we can just improve. So we got the basis from ChatGPT. What you can do, you have to like check what the result is like. So we didn't make any sense. We just improved it a bit. It was just 2 functions, one function within another function. The outer function was not serving any purpose, so I just got rid of that and improved it a bit. So now this works a bit better. So let's do another test with that. Uh, just copy from here so I don't have to type it all. So we want to test this function that we just a bit like improved and try to see what classes we get for temperatures -1 and -60. So if you just run this, it's telling you that -1 is below freezing point and -60 is also below freezing point, which is true. But then again, are -1 and -60 the same? But it depends on your application. But if you want to be more specific, maybe this is not the best categorization. But we cannot blame ChatGPT for that because we haven't provided enough instructions. So that was a brief overview of how ChatGPT can be used for creating codes. Just a few things to consider. Like first of all, one important thing to think about is privacy matters. So if you ever end up using ChatGPT for whatever purpose, remember that you should consider that this is kind of like public domain. So you're not really to talk. Your conversation may not be so private. We don't know how they use this information you provide. So do not share very personal information with ChatGPT. You don't know where that would end up. That might end up one day. And then, yeah, some conclusions. So if you use it, you have to be very specific, provide context, and remember that the answers that you get are not perfect. So if you use it, you have to like test it and make sure that it's the good enough solution for your purpose. So, yeah, do you have any questions?
How many of you have actually used ChatGPT previously already? Has anybody done? How many of you actually knew that you could write code with ChatGPT? Okay, so it seems like at least there's awareness of the tools. And yeah, I think the key thing here is just to note again that for the purposes of the course, the guidelines on the course page sort of clearly explain the situations when you can and can't use ChatGPT. We do want to sort of provide some opportunities to gain experience with this, but please pay attention that in particular, if you're using things like ChatGPT for answering the exercise questions and it's not stated clearly that you can, that you should not do so. But if there's no other questions, yeah, we can continue on with the next part of the lesson. The next part of what we're going to talk about is here about using script files. So what we've been doing so far is basically putting in our functions to code cells in our notebooks, which is a fine way to do things. But as you get more and more functions, it's often helpful to start to group those functions together into a single file so that like every time, like let's say you've got a notebook where you want to use the functions many different times, or many different notebooks where you want to use the same functions, it's not really that great to like copy paste them into the notebook every time. So instead, an option is that you can basically put them into a Python script file and then read them out of that script file whenever you want to use those functions. And for those who might continue on to this Introduction to Quantitative Geology course, this will be the approach we use for all the exercises in that course. We kind of build our own little library of functions throughout the course. But yeah, the basic idea of a script file is it is essentially a text file that is has the file extension .py, and it contains a list of commands just like you would normally type them in. So it's not like the only thing you can put in there is a function. You can put other things in there, of course, as well. Regular Python code is perfectly fine to put into a script file. But the idea for what we're going to do is we'll put functions in there. So in order to get started with this, I'm going to jump over to the CST notebooks and start following the instructions here in our notebook for today, and make that a little bit bigger so you can read perhaps a bit more easily. But yeah, our first step is we need to create a new file that we're going to use as our script file. So if you go up to the top here to File and then New, and then instead of selecting like Notebook or something, we're going to put New text file. Actually, we can select Python file in this case. So it will already know it's got the .py file extension. It is just a normal text file, so that's fine. And you should see that when you click on New Python file, you get this empty file called untitled.py. Now, for the sake of just being able to see things more easily, I'm going to drag this untitled.py down to the bottom. So in case you haven't noticed, you can click on the tabs in the Jupyter Notebook and drag them around. I'm just going to drag this down to the bottom so that we can see both the lesson materials and this file at the same time. You could also drag it off to the side or whatever, however you want to do things. Once you have the new Python file, it will show up in the file browser. I don't have mine visible right now, but it's there. And you can go here in the notebook and copy this Celsius to far function and just paste it into the notebook. I guess maybe just, was everybody able to make the new Python file? Yeah, good. So we have a function in here now that looks hopefully familiar to you. And that's great. We can also rename our Python file to be something perhaps more meaningful. So I think we can call it temp_converter.py. I think if you right click on the tab, you can rename it there, or you can go to the file browser. Either one is fine. But let's call it temp_converter.py. And so if you do that, you'll see that the file in the file browser will have updated its name, and we'll use this after we get done with adding a few more functions. We'll test things out. So yeah, this is just a normal text file. So you can just if you've got the tab selected, you can save it like normal. So file, save Python file, or on a Mac at least you can do Command S, or I guess probably Control S in Windows would save the file. So anytime you update things, you can save it. But let's grab a couple other functions here. We have our Kelvins to Celsius and Kelvins to Fahrenheit functions. We can just copy those. And since we follow the HEP 8 guidelines, we can put 2 spaces in between definitions of functions because that's what HEP 8 says we should do. And so you can then paste those in, and you should have now your 3 functions in here, and you can save the updated temp converter file with the 3 functions in it. So you can imagine already we've had like, I don't know, maybe 5 or 10 functions we've encountered so far, and if they're things you regularly use, it's nice to put them into a file, and we'll find out why that's a benefit in just a moment. So now we have defined these functions. They're available to us in this temp converter function. We just need to know how to use it. And in order for this to happen, we need to go here to this, making sure we're working in the right directory, and run what's called a magic command for Jupyter Notebooks, and that is %ls. ls normally would list files in a directory, and if you run %ls, hopefully you see these output files. So you should see things like functions, script files.ipynb, and you should also see your tempconverter.py in there. If anybody doesn't see their tempconverter.py, please raise your hand so that we know. Okay, looks like everybody got it, so that's good. Then we can skip past the rest of this stuff. We already know we're in the right directory. So then let's go to importing our functions. And we'll start by importing one of them. So we can say from temp converter. That's the name of our Python file. Import Celsius to var. So this is a little bit different way. We've seen importing things like when we imported the math library in the past. We did like import math, and then that was that. This is another way to read something in from a script file. So you basically would say from the file name without the .py, import, and then some function that's inside that file. So if you run this, you should get no output, but we should now be able to use our Celsius to Fahrenheit function. So we could, for instance, do print and make an F string that says the freezing point of water in, I'm just going to say F instead of Fahrenheit, is, and then we'll put inside the curly braces here, Celsius to Fahrenheit, F-A-H-R, and we'll put in 0 degrees for our Celsius temperature. And if you run this, you should see that the freezing point of water in F is 32. So I'll remind you, we're working in a different notebook than we were before. So earlier we defined the Celsius to Fahrenheit function in the functions notebook. When you move to a new notebook, it's like operating in a different part of the memory in the Jupyter Lab platform. So it doesn't know about functions you've imported in other notebooks. It wouldn't have access to this earlier Celsius to var function we defined. Instead, it's when we did this from temp converter import Celsius to var, it then read in this function and defined it from our script file. And it looks like it read it in properly because, again, 32 degrees Fahrenheit is the equivalent of 0 degrees Celsius, and that's the freezing point of water. Of course, if you want to import more than one function at a time, you can do that, for instance, this way. So from whatever the script file is, import and then list several functions with comma-separated values. Or what's often the preferred way to do it is to actually import the whole set of functions so you have access to all of them. So you could do, for instance, import temp converter as, and we'll call it TC. So we're just going to shorten this because just like when we imported the math library and you had to type math.sqrt to use the square root function, it's the same way it works here. We're going to read in something here, and if we want to use a function out of our temp converter, we're just going to make it so we can type tc dot and then the function name to use it. So like we have tc dot Celsius to Fahrenheit. So if we run this import temp converter as tc, we now have access to all of the functions in our list here, our 3, so that we could do like tc dot Celsius to bar, and let's put in 100 degrees so we can check the temperature of water boiling in Celsius. And you see that we get back 212 degrees, which is the expected value for that conversion. But we could also do Tc dot kelvins to Celsius. Kelvins to Celsius. And we could put in, for instance, how about 273.15 kelvins, which should be 0 degrees Celsius. And if you run that, you get back the value that's expected here of 0. So we're now able to use all of the functions out of this temp converter script file. And again, because temp converter would be kind of a time-consuming thing to type in, we've imported it and just renamed it when we imported it to be called TC, so it's easier and quicker to type. I'll maybe move this down just a little bit since we don't need to see the functions so much at the moment. Of course, we could also test out the other function, but we don't need to test everything here. So this is something we will do in this week's exercise. You're going to first start out by making some functions, and then the last part of the exercise, you'll be putting them into a script file and be asked to read them in from the script file and use the functions there just to get some practice with that idea. But as you'll see, like it's not really that maybe complicated. Basically, you just put your function definitions into this one file. And then that way, you don't need to define them all in the notebooks. For instance, for this quantitative geology course, just as an example, we more or less use the same functions and build more functions in each week during the course. And the idea is that you kind of continue to fill your script file with extra functions that you use over time. And then that way, in each of the exercises, you don't need to like copy paste in 10 or 15 function definitions to start the notebook, which would take a lot of space and look kind of ugly, but instead you can just read them out of the script file. Are there any questions about this? Okay, so as noted, you'll get an opportunity to explore using script files in this week's exercise, so if questions come up at that point, please feel free to ask. And if you're needing help, the exercise sessions on Thursday and Friday would be great places to ask. So I'm just going to drag this tab back up here to get it out of the way, and that way we can see the rest of the script files notebook. So the rest of what's here, I won't go through in detail right now, but it's basically a way to go one step further with our temperature conversion ideas, and that is to make something that's here called the temperature calculator, where you can have a function where you define a temperature that goes in kelvins, and then you can provide a parameter where you list what kind of conversion you want to do. Do you want to convert to Celsius or do you want to convert to Fahrenheit? And then based on that, the function will then give you back the value that is desired. So you can find on the course webpage the example of how this temperature calculator function is created, and there's also an example here about adding something called a doc string. We'll see this again and just toward the end when we look at the good coding practice for this week. But this is a little bit of documentation. Normally when you create a function, it's a normal thing to add a doc string as well, and the doc string basically describes what the function does in understandable language. So for the temp calculator, for example, it says function for converting temperatures in kelvins to Celsius or Fahrenheit. And it also then has a list of the parameters that are there. Sometimes you don't need this. If you have a really simple function, you might not need to list the parameters. But there are times when you have really complicated functions. There are, in everything we've seen so far, all of the parameter values are required or expected values. Like to use temp calculator, you have to give both a temperature in kelvins and the parameter for what unit you're converting to. But it's also possible to have functions that have optional parameters. So this list of parameters can get quite long. If you go digging through any documentation of Python libraries online, you'll find long lists of optional parameters that are able to be passed to the function but not required. And then it lists here the return, so the sort of expected value that comes back, which is the floating point number, and that's the converted temperature. So the docstring is indicated here with these triple double quotes, kind of confusing language, but it's triple quotes with the double quotation mark is the typical format for those. Anything in between the sets of 3 quotation marks will be commented out and seen only as documentation for that function. We'll see how to access that documentation at some point. But anyway, docstrings are a normal thing to put into defining your functions, and you'll be expected again to do this in this week's exercise. I think that's kind of it for the script files thing. So you can have a look on the course webpage if you want to see that in more detail. Now, what I'll do next is go on to something about modules. We've already seen this in some sense earlier, so it should be somewhat familiar. Modules are kind of the Python name for something that's called a library in other programming languages often. In fact, it says here the words module, package, and library are pretty much used interchangeably. So you may have heard one of those terms before. But these are basically groups of useful things like function definitions or constant values that are defined. And there's a huge number of Python libraries out there that you can find and use. I think we've seen examples already of using the math library. So I don't remember exactly what the lesson says here, but if we were to import math by typing import math, that basically makes the math library available for us to use. And so then we can do something like math.sqrt to do the square root. And let's pick is 143 one of them. I think that's the square root of 13. No, that's not right. It's one. Yeah, 169. So anyway, you can do square root function that way. You could do sine function, cosine, tangent, whatever you might like, absolute value. All that stuff is available from the math library. And it's loaded in and made available by typing import math. And then to use something from that library, you then say the name of the library, dot, and then the function you want to use. So this is to avoid any conflict with another square root function that could possibly exist elsewhere. So we've already done this loading modules thing before. There's also some things that are built in already, like the print function. So there's no need to import anything to use the print function. It is a built-in function in Python that's there by default and available to you. The kind of general idea with Python and with the way it operates in terms of functions and modules is that for everything but the absolute bare bones basic stuff, you need to import a library to use it. And that just keeps the sort of environment as lightweight as possible at the beginning. It's hard to foresee situations in which you wouldn't want to use the print function automatically, so that one's available in the built-in function in Python. But I think for anybody who's had any experience programming in C or C++, I think even to do that kind of screen output, you have to load a library normally to do that in C or C++, whereas it's built in Python. So it can't even get more stripped down than what we have in Python. And we saw the example with our script files of basically doing the same kind of thing where we typed in something like what looks like here. So if we want to rename a module, sometimes the module names are quite long, so we might want to rename them. And so we could have, for instance, here import math as M. So the math library is not the best example because math is already a fairly short thing to type in. If it was called mathematics or something like that, that might be a little bit more cumbersome. But we can import math as M, and then we can do something like m.sign of, I don't know, something close to pi. And we see we get a number close to 0, which is kind of what we would expect for a number that's close to pi. Sine of pi should be 0. So we can do m.sign if we import the library this way. And so that can be sort of helpful. We're going to use this library called pandas in starting from next week, and for the rest of the course we'll be using pandas. And the thing you'll see everywhere for people who use pandas is it's almost always import pandas as PD, just so you don't have to type in pandas dot whatever. When working with the library, there's lots of times when you type in pd dot something to interact with your data. As we saw before with our example from our script file, we can also from from math, for example, import the square root function. So just pick a single function we want to import. So from math, import square root. If I import it this way, what's different than before is I can now just type sqrt, and let's put in 121. And we can calculate the square root of 121, which is 11. So you'll notice that we didn't have to type math dot square root. We didn't have to type m dot square root. When you import something this way, it comes in just with this name that's specified here and makes it available as a function with that name. That can be a little bit dangerous because if there's a built-in function with the same name, you might overwrite the built-in function. So typically we suggest to not do things this way, but it's also the case that sometimes when you work with a very large library, it's just unnecessary to import all of the functions from the library if you just want to use one. So like I sometimes use a library called SciPy, and it's quite heavy. And oftentimes if we use a SciPy function, I basically just import the single function out of the library because it's just unnecessary to load everything. The math library is pretty lightweight, so it's not a big deal to import the whole thing. There's also an example on the course page of how to import a submodule. So we will use this plotting library called matplotlib. Again, it's abbreviated as PLT when people import it. But what you use when you plot with matplotlib is almost always the matplotlib.pyplot submodule. So the pyplot is a thing built in as part of matplotlib. So you can, instead of importing the entire matplotlib library, just get the pyplot piece. If you run these two cells, you'll get this nice line plot. We'll do slightly more exciting things with plotting when we get to week number 7, but just so you know, that's how to import a submodule. And again, that's described on the course page. One thing I wanted to just note here is you would perhaps have noticed that when we did this from math import square root thing, that looks a lot like when we did the from temp converter import Celsius to far. These functions that are in these modules are basically just Python script files. They're stashed away in a place that is found by your computing environment, so you don't necessarily see them in your local working directory, but they are basically just Python script files that contain these functions in their definition. So there is somewhere buried in the guts of Python a math.py script file that has things like definitions of the square root function. It's the same idea basically for what you do when you put your own functions into the script file. It works very much the same way. Yeah, maybe a couple other things about this, and then we can move to our last couple things for the lesson. But when you have these functions, sometimes it's not clear what all is available to you. So like with the math function, for example, it might be kind of unclear what kind of things can I do with the math function. So there is here a thing called dir, and basically it will give you a directory of all the functions that are available for some library. So if we do like print out dir of math, you'll see that these are all the names of functions that are available in the math library. So we can find, for instance, our square root here. There's our sine function, but as mentioned, you can also do things like calculating cosine. So there's cosine. There's logarithms you can deal with. There's constants that are defined in here, like math.pi, which we saw back in week number 1, I think. And of course, there's then arctangent and all of those things as well. That's fine. You can get some useful information that way. I'm just going to add a code cell here just to show you another thing that's helpful, and that is if you type in math.s inside of a code cell in Jupyter Lab and then you press tab, you'll get a drop down that shows you all of the possible ways in which you could complete the name of the function that starts with math.s. So there's math.sine, math.sine h, and math.square root. All of those would start with the letter s. So this is also another way in which you can kind of figure out, if you don't remember the name of the function or just want to know what's there, you're like, probably there's a cosine function. You could do math.c and hit tab, and then you would quickly find that there is indeed a cosine function. You can click on that and then put in whatever value you want. Math.pi, for example, and you get the value of -1. Again, that's kind of the expected thing. So in practice, when working with the notebooks, that's kind of how I tend to get the list of functions available. It's like just hit tab to see what possibilities come up. Once you have a given function that you're interested in, and maybe you don't know what parameters and things you can pass to it, you can use the help function and do like help math.sine, and then you can see that this is the help on the built-in function sine in the module math, and it says sine x, return sine of x, measured in radians. So you get the documentation that way. Yeah. Yeah. So in here, like if we did math.s, it's the tab key. It should be, at least on my keyboard, it's above the caps lock on the left side. Does anybody else have it that when they press the tab key, it doesn't do anything? Yeah, it should be basically like you're just typing something in, math dot whatever. I don't know what starts with D in math, and I hit tab, and then it pops up the drop down list there. Yeah, that's weird. I mean, it's a Windows computer? Yeah, you do have to be in a code cell. That's one. Yeah, if you're in a markdown cell, it will just basically put like a tab, like 4 spaces. Yeah, okay. Well, we can have a look after the lesson if you want, just in case you're curious. But yeah, another question? Yes, you would have had to import the math library first. So that's the other thing, is if you haven't done the import math part, then it will not recognize that there's a library called math to look for functions in. So that could be another possibility. Yeah. Okay, very good. So that's helpful. I mean, that's a really nice way to be able to quickly find a list of what functions are available to you. And that's something I tend to use. If you want to know about what the functions can do, then you can do this help with the name of the function inside there, and that's the way you can get the documentation. If we go back to our script files notebook for just a second, we never defined any functions with a docstring in them. But if we had the docstring definition in one of our functions here, when you do the help command, it basically gives you the documentation from the doc string printed out to the screen. So that's one of the reasons why it's good to make the doc strings in there, is that then you can quickly see the documentation for one of your functions. As you get more advanced in doing things in Python, your functions will get a little bit more complicated. You might have optional parameters. You might have things where like it takes a list as an input or it doesn't take a list as an input, and you can have that documentation there quickly available by using the help function with the name of one of your functions, and it'll tell you how the function works. So a couple things just to note about things you should not do. So there's a kind of couple like bad ideas. So it is possible to say from whatever library import star. So like if we did from math import star, it will bring in all the functions from the math library, but it will put them into the sort of normal namespace, meaning that they're not going to be part of this math dot some function name, but just like when we did the from math import square root, it would bring that in so that you could just type square root whatever. So this is a bad idea because when you import things this way, it puts them in and may conflict with existing function definitions or built-in things in Python. So for the sake of demonstration, I'll do it here. So if I do this, I mean, it's perfectly valid code to do it. And so then I could do like sine of something close to pi. And that works just fine, like it did before. I don't think there's anything in the math library that will directly conflict with names of functions that we have, but when we get into using pandas, when we get into using other libraries, they have often functions with the same name, and they may operate slightly differently. So the numerical Python library called NumPy has functions that do a lot of the same things as the math library, but they're optimized for working with array data. So it has a sine function, it has cosine, it has square root, all of those things. So if we had from math import star and then from NumPy import star, they would conflict with one another. And depending on the order in which you import them, you'll get either the math or the NumPy version of the function, which at least in some cases, they're not compatible with one another. So you shouldn't do this from something import star. It's much better to just import math or import a single function from a library like this, but not all of them. Also good when renaming things, like it's great that you can shorten the names of the libraries, but it should make sense. So like the example we said of import math as M, well, it's kind of a bad idea for two reasons. One, math is not very long to type in to begin with, but also M is not really necessarily clear what you're referring to, because you could also have import matplotlib as M. So whatever your abbreviation is, like PD is pretty much used almost exclusively for pandas. And PLT is almost always used for the matplotlib pyplot library. So, it could be confusing if you import it with something else, or if you do something really kind of unintelligent, for lack of a better way to say it, import matplotlib as math. There's a high likelihood you're going to confuse yourself or other people who look at your code, because now expected things that would be in the math library are actually referring to something from matplotlib. So, we'll show examples of what the typical standard is when you import some of the libraries we use, but just be aware that you should pay attention when you import things, if you rename them, to make sure the name makes some sense. And the last thing is just about the PEP 8 guidelines. So the suggestion is that when you import things, they should always be done at the start of your code. So at the top of the script file or in the first code cell, that's where you should do all of your imports. It makes it easier for someone reading the code to see, like, right away, okay, what libraries are needed or what modules are needed for this code to work. If you put the import statements in throughout the code, you can do that. It will run, but it's just less clear to the users, including yourself, for instance, what you're doing. So any questions about the modules? All right. Then I'll just quickly note here, we do have a good coding practice about writing our scripts the quote unquote right way. So this builds a little bit on things you can find in the PEP 8 style guide. So again, we refer you back there. But when you write your script files in a sort of good way, first off, there's inline comments. So Kamyar showed already how to add inline comments using ChatGPT. But of course, when you write your own code, you should also add comments in here that basically say what your code is doing. So for instance, here we can see that we're defining a station name, and there's a line above it that starts with a pound sign or hashtag or whatever you call that thing. And it says station name for the station Kaivopuisto, Helsinki, Finland. And everything on this line after this character is ignored. That's the comment. And that's a helpful thing just to kind of clarify what this line is here, or perhaps what the station lat and long refer to, especially that the longitude is east, because if you're working on the other side of the Atlantic Ocean, it's typical that the longitude is west. So you may want to add a comment in there just to make it clear to the users that that's how things work. You can also use line breaks, also known as white space, basically a way to kind of separate out the blocks of your code that go together. So I think this is improved readability, makes it easier for you to quickly look and understand things, especially compared to the example here. This is a little bit kind of harder to read, but just by breaking things up with a blank line here and there, you can make your code quite a bit easier to look through. And then as mentioned, there's these doc strings, these ways of documenting what a function does. And you can have doc strings both at the level of a function. If it's in a function, it's usually the very first thing underneath the function definition would be the doc string. But you can also put it in a script file. So it's perfectly fine to put these at the start of a script file that then describes what that script file contains. So there's examples here of how to create doc strings that you can look at in the good coding practice. And again, you'll be asked to do that in this week's exercise. So it's good to know where you can find some information about that. We also have some topics here like adding a license. Depending on how you're sharing your code or what you're doing with it, it might be that you need to license it. MIT license is one of the more permissive licenses, which basically just says that you can use the code for whatever you want, but you're not going to hold the person who produced the code responsible for anything that it does. So you can see, for instance, software is provided as is without any warranty, and there's no accountability for anything that the person uses your code for. However, they do have to abide by the license in whatever sense that means. And there are other more restrictive licenses that require people, for instance, to share the code with the same license if they're using it. That's not the case for the MIT license. Anyway, that's our good coding practice for this week. And we can then jump to our last thing, and that is our preview of exercise number 4. So I think I have that open here. Make it a bit bigger. So 3 problems in this week's exercise about functions, and you should be able to already clone your copy of the exercise on GitHub. I'll open up the first exercise problem here and just take a quick look at that. So no surprises here, I suppose. Our first exercise question or problem is about converting temperatures, in this case from Celsius or from Fahrenheit to Celsius. So we've been doing things the other way around, from Celsius to Fahrenheit, but now we're going to have you get some practice with making your own function to convert temperatures from Fahrenheit to Celsius. And you can see the equation that you would use to do that conversion here. And the idea is that you would produce a function that when you run, for instance, this print statement, 32 degrees Fahrenheit is equal to, then you put in far to Celsius 32 degrees Celsius. it produces the output that you see below. So you'll find some instructions about what to do here in the normal AI usage agreement thing. That statement is also there. There's some guidelines about what you should call your function, and then basically you'll add your function definition here and do some tests to make sure that your function is working in the way that you expect it to. I think problem number 1 is fairly straightforward, but it's a good opportunity to create your own function and see how things work, and add a doc string and things like that, which we haven't done yet in the lesson for today. Problem number 2, also perhaps somewhat familiar, is about classifying temperatures. We did this last week already, but now we're going to classify our temperatures using a function. So we're going to make a function called temp classifier that returns the following numerical values. So for any temperature that's below -2 degrees Celsius, you get a 0 back. For temperatures warmer or equal to -2 but less than +2, you get a 1, and so on. So there's 4 different values that get returned depending on the input temperature. You'll see again that the expectations of the function is called temp classifier. It has a single parameter called temp Celsius that gets passed in, and basically you make your function, and it should pass the sort of tests that are listed here to show that it's working properly. So the tests should kind of check to see if you've got all the right classes when you given the example temperatures that are here. This is the problem where there is the option at the end of it to also do the same task using ChatGPT. So please note you need to do the first part just using your own hands and brain. But for the second part, you are able to use ChatGPT to try to produce a temperature classifier function that we'll call AI temp classifier. And the way that this works for this part, okay, it's totally optional, no points. It's mostly just for, I don't know, fun. And the idea here is that what we want to see is the prompt that you give to ChatGPT and the code that it produces. So for the first part, please put in the very first prompt that you use for this exercise. It doesn't matter if the code it produces is total nonsense. That's fine. The idea is just to see, when you put in a prompt, what kind of code do you get out? And we want to see, the first case, what kind of code gets produced from the first prompt that you try to use. So you can just copy paste that in here, and then there's an opportunity for you to take a look at the code that ChatGPT produced and maybe give some comments about how it looks, if you see any problems or things like that. And then there's tests you can run with that code. Again, it's not worth any points, so the issue here is if it fails these tests, it's not so much whether you're getting the right answer for the exercise, but it's more does the function work properly? So it should pass these tests, and if it doesn't, there's an opportunity here to go and then refine the example function that was produced the first time around by adding additional prompts. So, it might be that it works, and that's great, but it may be that you have to give it kind of more information to explain specifically what needs to be done in order for the function to work as expected. And it's worth noting, that, probably if you got it right on the first try, I would say that's impressive, because it's going to be a little bit challenging because we're classifying things with a range of temperatures. So it will likely mean that you have to sort of do this kind of process iteratively a couple times, in which case it'd be good to list at least for the prompts, what the second prompt and the third prompt and whatever for these additional ones, you can just copy paste in what you typed into ChatGPT. And then the final code that you get produced from there, you can then paste into the cell here, run the test again, and then there's one more spot where you can give some feedback about your experience using ChatGPT to produce code. So we are also thinking for some of the future exercises in the coming weeks that we'll have an opportunity to do more stuff with ChatGPT, just so you can see how it works and learn a little bit of how you might be able to expedite your process of producing code. But the important thing is that it's still you have to be the one thinking. It's a statistical model. It's not intelligent. per se. So it might produce things that look very good, but you still have to be the one looking at it and going like, okay, does this really seem like it works? We're providing tests here to check and see whether your code works, but of course, in a real world scenario, you need to be the one who's testing and checking to see that the code works as it says. I have a colleague who produced a nice like Tetris game with ChatGPT after not even too many prompts. But each time you had to kind of check and see like, okay, do things work properly when you put a new Tetris block in? Does it like properly remove the row, or does it function as it should? So you have to be a little bit skeptical. Then the last problem here is about the continuation of problem number 2. So you made this temperature classifier in problem number 2. You apply it in problem number 3. So here you're given a list of temperatures. I think this is half-hour temperature values. I don't remember what time of year or whatever this is. But these are temperatures in degrees Fahrenheit. From the look of things, I'm guessing this is sometime in the winter or spring. But you have these temperatures, and you now want to use your temp classifier function to tell you how many of these temperatures fall into the different classes that we have. So I think we had whatever they were, like freezing or cold or something like that, and then slippery, warm, and hot, or something like that. I don't remember what the classes were themselves. But you're going to take this list of the temperatures and go through each one of them and then call your function and have it return back either this 0, 1, 2, or 3 value, and you're asked to then make these variables called zeros, ones, twos, and threes, where you can then store those values to know how many of the different temperature classes are represented in the data that we have. There's, again, some tests to run here, but I think that's more or less it for what part of exercise number 4. You have any questions about that? I will make a note here for exercise number 4. One thing that is sort of important here is we are going to be using a script file in the third problem. When you commit your changes in Git, you need to save the changes to your notebook, but you also need to add your script file and commit that when you save things. So you'll create the script file. You need to make sure you add it in Git and push that along with the changes you've made to the notebook, because otherwise we can't test to see whether your notebook and code are working properly. So please try to remember that. If we don't see it, we'll ask you for it, but it's much more convenient if you just remember to push the script file and the notebook at the same time. If there aren't any other questions, I think that covers things for this week. So we will see you in the exercise sessions, and next week we're moving on to our first taste of interacting with data using the Pandas library. So we'll see you next week.